Welcome to my channel. I'm Zhang Xu. Let's look at the problem 19 in chapter 6. In this one, this problem is a little bit tricky. It asks you to show the value of the acceleration due to gravity is changed if at the height of delta r above the Earth's surface. We do a lot of problems. We find yes, this g is changed, but how it changed? It tells us in this equation, right? We need to prove it. How can we do that? First thing we consider is acceleration due to gravity. So acceleration due to gravity, this one is decided by gravitational force. Do you agree? So the gravitational force equals mass times this g acceleration due to gravity. And then this g can be written in this way, the small m cancel. See, this acceleration due to gravity determined by mass of the Earth and also by r. Of course, the mass will not change, so if the r changes, the height of delta r changes, we need to find it, right? So how can this delta r changes? So we can see if the delta r changes, if the r changes to r plus delta r, and this g can be changed to g plus delta g. Do you agree? This is a change of the g. This is change of the r. We can write this equation. Agree? And then how can you solve this equation? Luckily, the problem gives us a hint. Use this equation. But then look at this equation. This equation is a term 1 plus or minus x n power n. It looks like we need to convert our equation. Look like this form. Then we can use this equation to expand it. Agree? So how can we do that? We just take the r out, and then we get this term. Agree? Yes. The next one, because we need to expand it, so we can write it as this way. So this g plus delta g, and then take this bracket, this term as -2. The power is just put it up. See, no problem, right? But there, g times capital M divided by r squared, what's that? It's just g. Okay, just g. So we can replace it with g times this term. Now we can expand this term in this equation. It is 1 plus delta r. So this part is just as r, the x, right? This -2 is just as n. See, exactly the same. Now we can do the expansion. We expand it. So g, and then the first term n is -2, and we just copy it, write it, and r is this term plus next term, this one. And then it looks like we proved because it just want to find the first term. See, the delta g just almost equal to this term, right? So this one can be cancelled. We can ignore this part, and then it equals this one, and then we find delta g just equals to this second term, this term, right? We have proved it. Now, what is the meaning of the minus sign? What is the meaning for that? The minus sign tells us if the delta r increase, the delta g will decrease. Agree? That makes sense. Yes, we did a lot of problems. We found at the spacecraft the g will become smaller, right? The next one, use this result to compute the effective value for g at a distance 125 km above the Earth. So in this one, tell you the delta r is 125 and the radius for Earth is given. Can you find the difference? Sure. After we input the number inside, you find it is this one. The g decreases these values, and then we fix it, and then we find the g is this value. If we directly calculate the g at a distance above the Earth, this one, it is almost the same. So it looks like this equation works. Thank you.